Hey, hello, how are you? Well, this is a video I have made or I'm making. I am making for to explain about the mechanism I put in the internet in YouTube. So I put it in English because there was a girl that write me in English about that she wants me to explain me the side of the bars that I am using for the mechanism. Well, I have got these bars from this from a part of cartoon that I put from a book of astronomy. Well, the thing is, she want me an explanation to explain her about the dimensions. Hey, take care. The dimensions of this, and as I have explained in the video, this is the part that is fixed to the plane in some case. This is a fixed part. This doesn't rotate, doesn't make anything. This is like the body where it is attached the mechanism. So here it is. This dimension is, I will say the dimensions because that's basically what she needs. This is 32 centimeters. So you can see this dimension is 32, and I say that the angle with respect to the vertical is 9 degrees. So it's 9 degrees. So that was the measure she needed. And the other thing is because I say that this dimension here from the vertical to this angle, to this vertex, is 5 centimeters. So you can measure 5, and here is 32 centimeters, and you will obtain an angle of 9 degrees. So that's the first thing. The second thing is this bar, this small little bar. I have already cut it. It's a little bit short, but I will cut it again. So this one is 12 centimeters. This one is 12 centimeters, as you can see. 12 centimeters. Here's the dimension. So this one is 12 centimeters, and this second is 32 centimeters. So that's the data of the problem, the first data. And this angle is 50 degrees. So if you can draw it maybe in AutoCAD or draw it in SolidWorks or even in your paper, in your book or in your notebook, then you will find this angle is 15 degrees with 12 centimeters, and this is 32 centimeters with 9 degrees. So what's the first dimension that you needed? And the second dimension that you need is the dimensions of these bars. These long bars, one is here that is 30 centimeters. I have already put this, and this 26, it will rotate in some way this way. So the mechanism will do something like this, and that's the motion that produced in the landing mechanism I have put here. And this is, well, that's the only data that you need, that this is 30 centimeters, and this is 26 centimeters. So, okay, so this 26 and this 30 centimeters. So now I explain how you would obtain this angle if you would do it graphically. I have put here 35 degrees centigrade degrees only, and this 23 degrees. And as you can see, when you are doing, there is two procedures. One is the graphic procedure, and the second is the analytical. I will explain only the graphical here. So the graphical here is, well, I have put also with this little dimension, you would see that it would rotate. This one is the one that rotates with maybe a motor or something, and that also will produce this motion. So that is what it's intended to do. So the way that we would obtain this angle is only we measure here 23 degrees, maybe with the ruler, for example this. So we measure the 32 centimeters is here. It's a little bit more than 30 centimeters. And the 30 centimeters we would rotate. We would do something like this. I would simulate that I have a compass. So I would do like this. So here the signal of the compass. And here with 26 centimeters, we would measure also the 26 centimeters with our ruler. We put here 26 centimeters is over here, and so we also rotate like this, so we would have something like this, and so we have the signal of the 26 centimeters, and in that way we would obtain this point. That's where the intersection, and then you can have a compass or something like that, and you would measure this angle, this 35 degrees, and we would measure with this 23 degrees. So the second part would be to build the mechanism. It's not difficult. You only cut the bars, cut these bars, and cut this other bar, and you would have a 4-bar mechanism. That's the name of this one, because we count also this one. So 1, 2, 3, 4 bars. And well, the second thing I would say is I would write just something here. I would write an equation here. Well, the equation that is very useful for this kind of mechanism is a circuit equation. We call this here circuit equation. And the circuit equation, let's see that we have 4 different bars. This is a vertex A, B, C, and D. So the thing that we would use is we only write this. We have AB, that's the dimension of the vector from A to B, plus the dimension B to C, plus C to D, the third vector, plus D to A. This that start in 8 and finish in 8, all these vectors, the sum must be 0. So that would be very helpful, because, for example, we have these 2 dimensions, we have the angles. So we only, in this case, we only need 2. We have 2 dimensions, but we need the 2 angles. So we have an equation where you can solve for these 2 angles. And in other cases, it would be a little bit different, but be the same. Maybe we have the dimension, but not the angle, and here we have the angle, but not the dimension. That would be another case. But well, that's my explanation. I hope that for this girl that made me this question in the video is helpful. I will maybe build a site where you can check all these videos about mechanisms, about maybe robotics, or maybe another things, or mechanics, or cinematics, all those things. So I will put a site and where you can consult this. So thank you. My name is Miguel Moctezuma. Thank you very much. And this time of pandemics, well, this is a way maybe we can keep learning and do something. Take care. Be careful.